All right, it is my planning period, and what am I doing? Your homework. Hopefully, I explained this in class how this works, but I haven't had to taught you this lesson yet, so several days are going to happen between now and then. You are supposed to solve a matrix equation A times X is B. Now, the layout for this, if my pen doesn't break on me, and it just did. It really had that wax on there good. I don't know if you could see it, but I literally just pulled the entire pen apart trying to get this little wax ring off of it. All right. The idea is if you have a matrix A and you multiply it by X and is B, to isolate this thing, normally we would just do division, right? We would say, okay, X is B over A. This is a matrix. There is no such thing as matrix division. It is not a concept. No, it has never been defined. It never will be defined. So what we do is we multiply both sides by the inverse of that matrix. You may or may not know what an inverse is, but like if you talk about X, its inverse is 1 over X. This is why we use the inverse notation here. But X times 1 over X would be 1. It causes a cancellation. That's what it does. It causes a cancellation. So these two die. Now I have actually solved for X. X is matrix B times the inverse of this. It says show the setup, use your calculator. All right. So to find your thing right here, and we'll probably have to change, we may have to put this one first. First thing we're going to do is we're going to find the inverse of A. I'll do that entirely in a calculator. I'm not asking you to do it by hand. You don't have that kind of time. You were shown how to do it by hand, but I'm not asking you to. Second matrix edit. A is a 2 by 2, and it is 8, negative 7, negative 6, 4. When I took my generation's equivalent of pre-calculus, this is how we were taught to use matrices to solve equations. We were not taught reduced row echelon form. I didn't learn reduced row echelon form until I took a computer science class and they asked me to program it, to write some code that actually did RREF. That was when I learned reduced row echelon form. And I don't know why it wasn't shown us, but it wasn't. Anyways, I typed it in, I quit. I'm going to hit that inverse key right there. And that, after I convert to fractions, is the inverse of A. Negative 2/5, negative 3/5, negative 4/5. And she is a 2 by 2. If you notice B is a 2 by 1. So what I wrote on paper up here, I got to have this guy out here for the actual multiplication to be defined because the inside numbers have to match. So I'm just going to multiply these two together. It's going to give me a result, and that will be matrix X. If I take a 2 by 2 and I multiply it by 2 by 1, I get a 2 by 1 as a result. Second matrix edit, scroll to B, 2 by 1, 11, oh, I've already got it in there. Cool. I'm actually just going to highlight this one to save me some time. I can't do that? I guess I can't. I think I can do this though. Times second matrix B. Yeah, I thought I could. It is 4, 3. That's what I've been looking for. All right, you can do 2. Let's see here. Bottom set says solve the system of equations using inverses matrices. You may have to use your calculator, but you have to show your matrices. See how I do it in the video if confused. And I'm just going to do 4. One of these may not be answerable. It may not have an inverse. So one of them may not be doable. This will be matrix A. Matrix A is called the variable matrix. It contains the coefficients. I'm going to multiply it by some matrix. I have no idea what's in it, but it's called X. And I'm going to get the coefficient matrix, which is 1, 1, negative 17. Now, this solutions matrix is going to be found by multiplying this guy by that guy's inverse. So that's how I'm going to figure it out. Second matrix edit, I need a 3 by 3 now, and she contains these coefficients that I wrote down previously. I'm just going to glance at the piece of paper. Quit out after I make sure they're in there right. Her inverse is that. Oh, those are horrible. That's better. Inverses of matrices are just disgustingly ugly numbers. The good news is it had an inverse, because if it did not have an inverse, I wouldn't be able to do the next step. So I'm going to take this matrix, I'm going to multiply it by the coefficient. I lost my train of thought here. I'm going to multiply it by the coefficients matrix. And she is a 3 by 3. That's a 3 by 1. And I'm going to get this guy right here now. I'm going to figure out what that guy is. It's not a hard skill. I do have to put a 3 by 1 into matrix B. She contains the elements 1, 1, negative 17. Quit out. Since this is the last thing I have in my calculator, I'm just going to hit times. And here's my results, 0, negative 7, 5. And I'm supposed to actually solve the system here. Well, x is 0, y is negative 7, and z is 5. So I get this order pair 0, negative 7, 5. The technique you're using is a nice, easy technique. What it cannot do is it cannot solve inconsistent systems. Well, let me just say this. It cannot determine if a system is inconsistent or dependent. RREF is superior to this technique because RREF can solve dependent systems and it can tell you if a system is inconsistent. Reduced row echelon form is the superior way to solve matrices. It really is. Anyways, I'm only going to do one of those. It's not that hard to do. So you should not need just detailed instruction on that. If you do, you might be beyond the scope of me helping. I'm only going to do one word problem because you need to figure out some of it. I guess I'll do the Stevie one. So Stevie wants to make 3 different types of cereal to create a mixture with 3,400 calories, 90 grams of protein, and 90 grams of fiber. We'll just call that X, we'll call that Y, and we'll call this one Z. Cereal A has 300 calories. It has literally 300X. Cereal B has 300X. Cereal C has 320X. All right. Oh, sorry. Forgive me. I don't need to be labeling these things like that. Cereal A, cereal B, cereal C. What I'm going to do is I'm going to write an equation for calories, for fiber, and for protein. I'm going to write 3 equations. One of them's for calories, one of them's for fiber, for protein, and the last one is for fiber. And I'm just going to use the letters A, B, and C. So let's talk about calories. Cereal A has 300 calories, 300A, plus cereal B, 300B. plus cereal C, 320C is 3,400. Next thing we'll talk about is protein. Cereal A is 11. Cereal B is 7. And cereal C is 8. And the goal is 90 grams of protein. And then we have fiber. Cereal A is 8. Cereal B is 6. And cereal C is 10. And he wants 90 grams of fiber. And our job here is to find the best mixture of these three cereals. Take the best parts of each one of them. All right? And we have three equations. Now I am going to transfer this into a matrix without doing the work. I'm not going to write it out. We have a 3 by 3 here. I guess I do need to show it. We have a coefficients matrix, 300, 300, 320, because it's the only way you're going to remember it is by writing stuff. I mean, I legit remember writing this stuff as a kid. I do. I remember writing it down. That's probably why I still remember it to this day. We're going to multiply it by some matrix. That's going to give me some X's, some Y's, and some Z's. Or sorry, A's, B's, and C's. It's going to give me those values that I want. And it's going to equal the coefficients matrix, 3,400, 90, and 90. And again, we talked about this when I did the first problem. This matrix, its results, I'm going to find it by taking the inverse of this dude. So let me find the inverse of that dude. Look at those horrible fractions. The reason we use fractions is because you kids will do things like round to the nearest tenth and wonder why you're wrong. It happens every year. It doesn't matter what class I'm teaching. If I'm teaching a class of pre-calc, which is supposed to be all of the best ones, kids round. If it's dual enrollment, which is the best ones, kids round. You're not supposed to round, so we use fractions. And we take that inverse and we multiply it by the coefficients matrix. So I'm just going to put that in B real quick. Choose a 3 by 1, 3,400, 90, and 90. And it's going to tell me how much of each cereal I need to mix. And I guess this is per serving. So times matrix B. 2, 4, 5. So my mixture is 2 servings of cereal A, 4 servings of cereal B, and then 5 servings of cereal C. That, you have to forgive me, I'm really tired and I'm forgetting some words I should be saying here. That is the best mixture of the cereals, and that wasn't what I wanted to say. The most efficient mixture. Still not the word I had in my mind, but that's how you do it. I know that much. So I didn't do a whole lot of your homework. I did all the ACT, and I think I did 3 other questions. That's still pretty darn close to half. Let's see, you had 9, 10, 11, 12, 13, 14, 15, 16, 17. Well, yeah, after ACT, I did 11 of 17 questions for you. So that's plenty. That's plenty.